Hello guys, in this lecture we are going to talk about the problem of classification accuracy in imbalanced data and how to overcome it. Let us first download the dataset we are going to use from Kaggle site. Okay, so let's read the description of this dataset. The dataset contains transactions made by credit cards in September 2013 by European cardholders. This dataset presents transactions that occurred in 2 days, where we have 492 frauds out of 284,807 transactions. The dataset is highly unbalanced. The positive class frauds accounts for 0.172% of all the transactions. Now let's download the dataset. Okay, so I have already downloaded the dataset. Now let's explore it. We can see that there are 31 columns. The last column is our target, which indicates whether there was a fraud or not, where 1 indicates fraud and 0 indicates not fraud. And the other 30 columns are our features. We also have 284,807 instances, so it's not a small data set. By looking at the data, we immediately notice that we need to normalize it because of the variety of the features values. But there is no need for one-hot encoding because we don't have any categorical features. We can also apply feature engineering as we learned in the previous section to improve our model performance. But now, let's look at the distribution of values among the two classes. We can see that this dataset is highly unbalanced. We have over 284,000 instances belong to the not fraud class, and only 492 belong to fraud class. Okay, now so let's split our data to train and test, and then see the accuracy of logistic regression model over our dataset. The accuracy is 99.8%, which is almost 100%. So this is an excellent model performance, right? Well, let's make sure. We will create a dummy classifier which will always predict that there was no fraud, so the prediction will always be 0. And let's see the accuracy of this dummy classifier. The accuracy is 99.8 also. So how did that happen? Well, detecting every transaction as not fraud gives an accuracy of 99.8%. The model did nothing here, but just gave us not fraud for all the predictions. That's because classification accuracy is the ratio of the number of correct predictions to the total number of input samples. We surely need better alternatives, and that's what we are going to learn in the next lecture. So stay tuned and see you guys.